Determine the equation with the least degree for each polynomial function. So because it says least degree, we want to assume that the zeros given are all the zeros, and we're not going to assume any other information. So we have a cubic function that tells us the degree with zeros at -3 with a multiplicity of 2. So I'm going to draw -3 here, and a multiplicity of 2 means it bounces, and a 0 at x is 2, and a y-intercept at -18. I'm going to have to scale this, so let's go 2, 4, 6, 8, 10, so that's going to be -10, 12, 14, 16, -18. So there's my y-intercept at -18. Okay, and to make this work, it has to be a positive leading coefficient. Now it doesn't tell us this, but if I try to draw this with a bounce here and through there, it's impossible to get it through the y-intercept. So in order to make this work, it has to come in this direction. So the a value has to be positive, and then we're going to go through like that. Now that's not a great looking graph, so I'm just going to sketch that again. Okay, it's probably going to be more steeper like this, and through these points like that. And we don't know if the vertex is on which side of that y-intercept, and we're not expected to know that at this point. In calculus, we will learn how to deal with that. For B, it says we have a quintic function, so that means an power 5. We have zeros at -1 with a multiplicity of 3. So I'm going to stretch this out a bit. So there's my -1. There's going to be a slide through that point, and 1 at 2, and this has a multiplicity of 2, so it's a bounce, and the y-intercept is at -4. So we're going to draw that y-intercept as -4 here. So it's a 5th degree function, and in order to draw this, it has to go in this direction, okay? Because to get it to go through that y-intercept with a slide through there, it has to be a negative leading coefficient. If we try drawing it from the other direction, you'd see that there's no way we can get it to go through that y-intercept without introducing another 0. So it has to be in this direction. So that's going to be B. C, it says we have a quartic function, so that means it's a degree 4. It's got a negative leading coefficient. In this case, it tells you which direction it's opening, so it's going to be opening down like that. And it has zeros at -2. Okay, so I'm just going to stretch the axis here, so it's -2. It's going to be a bounce there, and at +3, so there's +3, and it's going to be a bounce here. And a constant term of -6, that also means that that is the y-intercept. So my y-intercept is at -6. And to make this work, it's got to be upside down, it's got to bounce, it's got to go through that, it's got to bounce again, and keep going like that. Okay, and again, we don't know if the vertex is on that side, the vertex could be on this side, we don't know. Okay, and again, we're not expected to know that, and we won't need to worry about that till we get into calculus, when we have some tools to deal with that vertex.